Alright, so we're going to start Chapter 2, Section 1A. We're going to start just by discussing linear equations in two variables. Up until now, we've done linear equations in one variable, and that typically just looks like solving an equation. Like, let's say maybe you get like 2x minus 3 equals 11, something like that. That would be a linear equation in one variable. Right, but we're going to discuss a little bit more generally. So we're going to look at maybe y equals 2x minus 3, something like that. Okay, so in this slide, we're going to talk about the three forms in which we're going to see linear equations in two variables. The most common one is going to be our slope-intercept equation, right? And you've definitely seen all of these before in Algebra 1. I feel like slope-intercept gives you the most information. It's the easiest to graph because you already automatically have a point. Your y-intercept, it's going to be written as 0, comma b, right, as an ordered pair. And that's just going to tell you on the coordinate plane, the xy plane, maybe b is somewhere right here, right? This is our y-intercept b. Right, we immediately know from slope-intercept form where to graph it or where it goes. And then the slope is going to tell you where to go from there. In the next slide, I'll show you how to find the slope and what it means really. But it's really just a measure of steepness, how steep a line is going, right? So maybe the slope is telling you to go up and over a certain amount, and then you end up at another point, and then another point here, and another point here. And then you can just connect all those points and you get your line. Right, so slope-intercept, I feel is the easiest to graph. Point slope is also gives you a point to start at. Once you're given a slope, right, so once you're given your slope, this is the same m that's in slope-intercept form. But once you're given a slope and you know a point, right, whether it's the y-intercept or if it's x1, y1, like in point slope form, right, so we could have the same kind of scenario, right? We have an x, y plane, but this time we have a point and we're given a point right here, right? This is maybe x1, y1, right? The slope, again, is just going to tell you where to go from there. So you might go up and over a certain amount, right? And you go in either direction and then you connect right here, right? So it's just as useful. The most common one, like I've said a couple times already, is going to be slope-intercept, but with point slope, it does give you a decent amount of information. Once you know a point and you know a slope, you're able to graph your line, and that's enough information to tell you where to go. All you really need are 2 points, right? If you have your x1, y1, and you have your slope, you can easily find a second point, and then you just connect them, and then you get your line, right? Hopefully you guys find in this lesson that graphing linear equations in two variables are super easy, right? They shouldn't really be super difficult. The other kind of equation that you're going to see is an equation in standard form, right? This one you're given coefficients a, b, and c, right? So we don't see a, b, and c in the others. Well, you see a b right here in slope-intercept form, right? But this is not the same b. That's your y-intercept, right? It's a different, it's something else entirely. Standard form, I will say, is especially useful when finding intercepts, right? Because if you want to, let's say, set x equal to 0, right, then you're left with this equation, by equals c. And then you just divide both sides by b, and then you get your intercept, right? So maybe, again, you have an xy plane right here, and then you get a y-intercept. Maybe your y-intercept is going to be somewhere down here, right? And then maybe, hold on, let me erase that. Maybe we want to find the x-intercept, so we get rid of this by plugging in 0 for y. I'll show you how to do that in the next examples if you're confused, but if you plug in 0 for y, then this just goes away. So we have ax equals c, and then you can divide both sides by a, and then you get your x-intercept. Maybe that's going to be somewhere right here. And then once you get your 2 points, you're able to graph, right? Again, all you need is 2 points. In standard form, you're able to find the slope as well, right? You don't need to memorize this, but it's going to be negative a over b, right? So that's kind of the most useful part of it. along with finding the intercepts, you can find the slope from it. You'll see down the line that if something is in standard form or something that looks like it's in standard form, you might want to try putting it into slope intercept form before you try and do anything to it, right? That might be the easiest way to go about it. All right, on this slide, we're going to talk about slope and intercepts. We talked about slope kind of already. It's just a measure of how steep something is, and we use the letter m to denote it. So m equals all of these, right? Your change in y over your change in x. If you've taken chemistry or are taking chemistry, or you maybe see instead of change in, you might see this delta symbol. So delta y over delta x. And this is just, I won't really be using it. It's just so that you guys know that if you see this anywhere, like maybe the SAT or any sort of standardized test, you'll know what that means, right? That delta y over delta x just means the change in y over the change in x. To graph something, it might be easier to think of it as your rise over your run. Your rise is going to be how your graph moves vertically, so up and down, and then your run is going to be left to right. All right, and then the actual mathematical way to actually calculate a slope is to use this formula right here, y2 minus y1 over x2 minus x1, and this is if you're given 2 points, so x1, y1, right, and x2, y2, right? So if you're given 2 points, you're able to just plug them into your slope formula, and then you can find m right away. All right. Your x-intercept and your y-intercept. So your x-intercept is going to be when y is 0, right? So this is on your x-axis, right? So if this is your xy plane, right, when y is 0, right, so that's going to be this entire section right here. That is the x-axis. So when y is 0, then you get a number. Like, let's say this is your number right here, and that's your x-intercept. And you always want to write it as an ordered pair, right? So an ordered pair, a number, comma, 0 is going to be your x-intercept, right? Think of it the same way as the y-intercept, right? If you have a y-intercept, again, it's just when x is 0. When x is 0, that's this line right here, right? The y-axis. And then you have a point maybe somewhere right here, and that's your number, right? And again, that number is just when x equals 0, and you're going to write it as an ordered pair, right? So it's just where the graph intersects the y-axis. All right, and now let's quickly talk about vertical and horizontal lines. So a vertical line is going to have an equation that is x equals a number, right? So maybe like, I don't know, x equals -2, something like that. If you have a plane like this, your xy plane, right, where is x -2? It's going to be back 1, back 2, right? It's going to be this entire line right here. This is your line where x equals -2, right? And the slope here is going to be undefined, right? It doesn't have a slope. Again, think of slope as like a measure of steepness. If you have like a line that's like kind of flat-ish, right? It's going to be you're not going to have a super high slope, right? If you have another one that's maybe super steep, right, you're going to have a higher slope. You might have a really steep line, but it's going in the negative direction, right? This one is just straight going up and down, right? It is super steep, right? It's not defined. It is an undefined slope, right? So anytime you have a vertical line and you're being asked what the slope is, it's going to be undefined, right? So super important that you remember that. The other kind of line that you're going to see that has one variable is going to be a horizontal line, right? So again, notice that with your vertical line, you don't see a y. Same thing with your horizontal lines, right? You're not going to see an x. You're going to have y equals a number. I'm just going to say y equals 3, right? Y equals 3. If this is y and this is x, 1, 2, 3, you're going to have this entire line right here as y equals 3, right? Because this is everywhere in your coordinate plane where y equals 3. And this slope is going to be 0, right? Again, think of the slope as like a measure of steepness. If it's going completely flat, right? It's not going to have any slope, right? It's going completely flat. This slope is going to be 0, right? Different from an undefined slope. Okay, so let's start graphing. Let's look at the first one. So this is something that you can maybe recognize as being in slope-intercept form, right? You have a y by itself, or you have something in front of an x, and you have a constant, right? All you need to know here is to label m and b, right? So again, think of m as the number in front of x, and think of b as your constant, right? So m and b, right? Your m here is going to be 2 over 3, right? So I'm going to write m equals 2 over 3. That's the number in front of your x. And again, think of the m as your rise over your run, or the change in y over the change in x, right? So if your rise is the number on top, then that means you're going up 2 units, right? It's a positive 2. And your run is a positive 3. That means you're going to the right 3 units, right? Your y-intercept of 1, right, so b equals 1, just means on your y-axis, you're going to draw a point right at 1, right? So right there, all right? One way that you can think of it, the b is where you're going to begin, right? Always start by plotting your y-intercept first. And then your slope is going to tell you where to move from there, right? So b, you can think of it stands for begin. The m, you can think of it as standing for move, right? That's where you're going to move from your y-intercept, right? So once we plot our y-intercept, we know our rise over our run is going to be up 2 and over 3, right? We're going to go up 2, 1, 2, and then to the right 3, 1, 2, 3. And then we end up at this point. Now really we can keep going, right? 1, 2, up 2, and then to the right 3, and we end up right here. We can even go down and to the left, and then we end up at that point right there, right? Because down is a negative, right? It's going to be negative 2, but then to the left is negative 3. And then what happens to those negatives? They cancel out, right? So you can really go in either direction, right? Down 2 and to the right 3, and to the left 3, sorry. And again, all you need are 2 points. I'm just showing you that you can really go as far as you want. And then you're going to want to connect these points. And then there's your equation. Right, there's your first equation, y equals 2/3 x plus 1. All right, good. So now let's look at the next one. Right, we're going to have something similar happen here. Right, so again, this is in slope-intercept form already. We have a y equals mx plus b. Your m is your number in front of the x. Your b is the y-intercept. All right, so let me go ahead and write that down. M is -4, and b is 1. Again, b, begin, right? You're going to begin at your y-intercept of 1. All right, and then m equals -4, right? We can't really do our rise over run the way it's written like this. So very simply, just write this -4 over 1, right? Anything over 1 is itself. And now you can clearly see that your rise is -4 and your run is a positive 1. Again, if it's a negative, that means you're going down, right? So we're going to go down 4 units, and a positive 1 means we're going to the right one, right? So let's go down 4, 1, 2, 3, 4, and let's go to the right one. All right, and then you just need to connect these 2 points. Another way that you can go is you can go up 4, right? So 1, 2, 3, 4, and to the left one. That's still going to get us a slope of -4, right? So in either direction is fine, right? And then you just want to connect these points. All right, and there's in red your line, y equals -4x plus 1. All right, good. So now look at the next one. It's not always going to be handed to you, right, in a form that you already know, right? So sometimes you're going to have to do a couple extra steps to get it to look like something that you're able to work with, right? This on its own, 3y equals 2x minus 1, you can't do anything with that yet. But very simply, all you need to do is just divide everything by 3, right? Because once you divide everything by 3, you get the y by itself, and then you can get it in slope-intercept form, right? The 3 and the 3 cancels, so we get y equals 2/3 x minus 1/3. And there's your equation in slope-intercept form. And then again, look at the number in front of your x. that's going to be your m, and then negative 1/3 is going to be your y-intercept. All right, so m is 2/3, and your slope, your y-intercept is negative 1/3. So we're going to go on this graph right here, and we're going to find our y-intercept at negative 1/3. That's going to be a little bit below the x-axis, right? It is a negative number, but it's a fairly small negative number, so it's going to go somewhere right there, right? It doesn't have to be precise. And your slope of 2/3 means you're going up 2 and to the right 3, right? It's your rise over your run. So again, doesn't have to be precise. We can go up 2, 1, 2, and to the right 3, 1, 2, 3. This is going to be somewhere right here. All right, and then now you just want to connect those 2 points. All right, and then one thing to notice about that green and that blue line, they're going exactly in the same direction. All right, this is a special case where we have parallel lines, right? And parallel lines, the special thing about them is if you look at their slopes, they are exactly the same. Right, we have a slope of 2/3 right here, and we have a slope of 2/3 right here. Right, parallel lines have the same slope, and we're going to talk more about that in the next section. All right, but it's just something to observe for now. Okay, and then number 4, notice you only see a y here. You don't see an x, right? If this is the case, right, we talked about it in the previous slide, this is going to be a horizontal line, right? So we're going to want to get y by itself. So let's divide both sides by 3 to cancel out that 3, and then we get y equals 5/3, right? If you have y equals, you're not going to have a slope. The slope is going to be 0, right? So all you have to do is find 5/3 on the y-axis, right? That's where your point's going to be. And then you're just drawing a horizontal line. All right, so in orange is your horizontal line. Again, no slope. All right, it's not going up or down at all. It's staying level. All right. And now, last one on this page is number 5. Again, similar to the last one, we don't have a y this time, right? So think about it. What kind of line are we going to get if we don't have a y and we only have x equals? So this one's going to be x equals 1/2. All right. So on your x-axis, you're going to find where x is 1/2. And then you're just going to draw a line going through it. This is a vertical line, right? And think about what kind of slopes vertical lines have. All right, so vertical lines have undefined slopes, right? They don't have a slope, right? So I'm going to write that down actually. For our orange line, y equals 5/3, m equals 0. And for our purple one, m is undefined. All right, and that's all for this page. All right, we can keep going with some examples. If you look at something like number 6, we see negative 3x plus 2y equals 6. This kind of takes the form of a line in standard form, right? If you remember, standard form was our ax plus bx equals c, or no, plus by, sorry. So we have ax plus by equals c, right? And we want a, b, and c to be integers, and we want a to be a positive number. Here it's a negative number. It's fine. It's not really a big deal. We can still work with it. Now, I had mentioned earlier that an equation written in standard form is typically best for finding the intercepts, right? So finding the x and y intercepts. I'll show you both how to do it by finding the intercepts and by converting to slope-intercept form. So to graph this line, finding the intercepts, right, to find the x-intercept, okay, we're going to need the x and the y. The x-intercept is when y equals 0. So plugging in y equals 0, we get negative 3x plus 2 times 0 equals 6. All right, and then 2 times 0 goes away, and we get negative 3x equals 6. Divide both sides by negative 3 to get our x-intercept, right? We get x equals -2. So our x-intercept is going to be at -2 comma 0. And we just want to plot that point. All right. And now for the y-intercept, we're going to plug in 0 for x. All right, so we get -3 times 0 plus 2y equals 6. And then -3 times 0 goes away, and we get 2y equals 6. Divide both sides by 2, and we get y equals 3. So our other intercept, our y-intercept, is going to be at 0 comma 3. And then we have a point right there, and then to graph the line, all we have to do is connect the 2 points. All right, and there's our line. Now that's how to do it by finding the intercepts. The other way that you can do it is just to convert it to slope-intercept form, right? If you're comfortable with the intercepts, you don't have to write this down, but if you would like, I'm just going to rewrite the equation up top and show you how you would do it by converting to slope-intercept form. To convert to slope-intercept form, we want the y by itself, right? And right now it's not by itself, so what we're going to do is we're going to add 3x, right? We're going to do, what's it called? Reverse order of operations, right? So first let's add 3x to both sides, and then we get 2y equals 3x plus 6, and then it's any multiplication and division, right? So let's divide everything by 2. And then we get y equals 3 over 2x. 6 divided by 2 is 3. And then if you're comfortable with this, you would see that the slope is 3 over 2, and the y-intercept is 3. And as you can see, we have that on our line already, right? Our y-intercept is right here, which we already got. And then we're going to go up 3, 1, 2, 3, and then over 2. And then we make it at this point right here, right? So that's the graph of the line. That's how you would graph it if you wanted to put it in slope-intercept form. All right, so if you look at number 7 now, you'll see that it looked kind of similar, right? So we kind of have some of the same values or some similar values, but it's not quite in standard form, nor is it in slope-intercept form. But I'll do it by converting into slope-intercept form, right? So let's get the y by itself, right? We see the y, it's right here, right? So this is what we want to get by itself. So let's subtract 3 from both sides, and then we get -3x minus 3 equals 2y, and then divide everything by 2. And then I'm gonna write it flipped, right? Just so that the y is first, right? The 2's cancel out, and we got y equals -3 over 2, x minus 3 over 2. And then we know that our slope is going to be whatever's in front of the x, so -3 over 2, and our y-intercept is going to be our constant, right? So also -3 over 2. So I'm going to find on the y-axis where -3 over 2 is, plot a point there, and then your rise over run, right? We have a -3, so it's going to go down 3, and to the right 2, right? So 1, 2, 3, 1, 2, right? So we're going to end up somewhere right there. And then we can do the same thing in the other direction. We can go up 3, 1, 2, 3, and to the left 2, right? As long as our slope is negative. And then you just want to connect those 2 points, or in this case, 3 points. And then this is your line. All right, good. Let's look at number 8. Number 8, we have just an x, right? If you just see one variable, either x or y, you're either going to have a horizontal or a vertical line. If you have an x equals this one, we should expect a vertical line, right? Let's add 1 on both sides. And then we get 4x equals 6. Divide both sides by 4. And then simplifying 6 over 4, it's going to become 3 over 2. So I'm going to find on the x-axis where 3 over 2 is. It's going to be somewhere right there. And then it's going to be this line right here that's going through x equals 3 over 2. Right, so something like that. All right. Okay. Let's keep going. So number 9 is another one that kind of looks like it's in standard form. We can try either finding the intercepts or converting to slope-intercept form. Converting this one to slope-intercept form might be a little bit tricky just because we have a fraction in front of our x, right? So when we go to divide by that 4, it's going to be a little bit tricky, right? So that's why it's important to know several ways of graphing a line. Just because if you know you're going to mess up fractions, if you're not good with dividing a fraction with a whole number, then maybe that's not something that you would want to do. You want to maybe try finding the intercepts, right? So I'll show you how we would do that here to find the intercepts. To find the x-intercepts, again, we want to set y equal to 0. So we get 2/3 x plus 4 times 0 equals 7, and then 4 times 0 goes away. Okay, so we're just left with 2/3 x equals 7. And then to get the x by itself, hopefully we know that we have to multiply by the reciprocal. Right, so we do 3/2, multiply by that on both sides. And then over here it cancels out, and then we get x equals 7 times 3/2. We're going to multiply the whole number with the numerator. Right, so 7 times 3 is going to get you 21/2. All right, and then we get our x-intercept is going to be 21/2, 0, right, is our x-intercept. If you don't know where this is, do long division and see what you get, right? It should get you 10.5 when you go to divide it, right? But that's going to be somewhere off the graph right here, right? So it's going to be somewhere right there. All right, and we're going to do the same thing finding the y-intercept. Right, so to find the y-intercept, we want to set x equal to 0. And then we get 2/3 times 0 plus 4y equals 7. All right, this goes away, and we get 4y equals 7. Right, divide both sides by 4. And we get y equals 7/4. So our y-intercept is going to be the ordered pair 0, 7/4. And then 7/4 is a little bit less than 2. Right, so it's going to be somewhere right here. All right, and now that we have 2 points, we can just go ahead and connect them. All right, so something like that. All right, mine's not perfect. I'm a little shaky and wobbly, but as long as you have the points where they're supposed to be, and you show that it's an arrow, right, going in both directions, right? So write the double arrow, right? I think maybe a lot of you will just connect the 2 points and leave it at that and make like a little line segment. This is a line, right? If you remember from geometry, a line goes forever in both directions, right? This is a line, right? So draw the little double arrow, one on this side and one on this side, just to show that it's going forever in both directions, right? Okay, good. Hopefully we're good with that one. And then number 10, the easiest way to do this one, right? Look at it, look at the way it's set up. The easiest way to do this one is to convert it to slope-intercept, right? So divide everything by -3, because we already have -3y by itself, so it's not going to be that much harder just to divide everything by -3. All right, so we get y equals -2 over -3. Negative divided by negative is going to become positive, so we get 2/3 x. Same thing with the -1 over -3. It becomes a positive 1/3. All right, and then we're going to find our y-intercept is going to be 1/3, and our slope is going to be 2/3. Our slope is positive, so it's going to be up 2 and over 3. So I'm going to find on the y-axis where it's 1/3, it's going to be a little bit above 0. So it's going to be between 1 and 0. And then our slope of 2/3, 1, 2 is up, 1, 2, 3 to the right. And then we can just connect those 2 points. All right, now that's all for graphing lines. All right, let's continue with some examples. This page and then the next one is just going to be about finding slope. So when you're given an equation, you always want to put it in a slope-intercept form. If it's something that says x equals a number, that's a vertical line and those don't have a slope, so you would say it's undefined. And if it's y equals, then it's going to be a horizontal line. Those have a slope of 0. If you're given 2 points, right, there's a couple on this page where you're given 2 points. You're going to use the formula y2 minus y1 over x2 minus x1. Right, and this is if you're given 2 points, right? If you're given an x1, y1, and an x2, y2. All right, that's when you're given 2 points. But again, if it's an equation, you're going to want to put it in slope-intercept form if it has x and y. Right? If it only has one of the two, if it just has an x and it just has a y, it's either going to be undefined or 0. Right? So let's try some examples. The first one on this page is already in slope-intercept form, right? And the number in front of the x is 3. So this one very simply is just going to be m equals 3. Right? Not bad at all. The next one is one that has just a y. Now remember, if it's just a y, right, we don't see an x. This is going to be a horizontal line. And then hopefully we know what kind of slopes horizontal lines have. You can immediately say m equals 0. You don't need to go ahead and solve it, right, because the actual answer isn't going to help you find the slope, right? Now let's say you did solve it, right? You can subtract 1 from both sides and then divide by 2, and then maybe you get y equals 3. Right, some of you might get confused and say that your slope is 3. Your slope is not 3. This is a horizontal line crossing the y-axis at 3. Right, so this 3 is not the slope, right? It's 0, right, because it is a horizontal line. All right, okay. Now this one's an example of one where you have to use the slope formula to find the slope. Now you can label them, right? I'm going to say that this is x1, y1, and this is x2, y2, right? Then you can just plug it right into your slope formula, right? y2 is going to be 7, y1 is going to be 3. And then x1 is going to be, or no, x2 is going to be 4. x1 is the same thing, so we get 4 over 0. Can we have 0 in the denominator? All right, we cannot have 0 in the denominator. When this happens, if 0 is in the denominator, this is an undefined slope. Or you can say m is undefined, right? Because remember, 0 in the bottom, no, right? That is not okay. This is actually a vertical line, right? So if you see that the x value doesn't change, right, that's an example of a vertical line. Right, so it crosses the x-axis at x equals 4. Right, so this is an example of an undefined slope. All right, now let's look at the next one. 2y equals 2/3 x minus 1. All right, we also want to get the y by itself to get it into slope-intercept form, right? Here we see x and y. All right, it's almost in slope-intercept form. The only thing that you have to do is divide everything by 2. Notice, though, that there is a fraction in front of the x. Another way that you could solve this, dividing everything by 2, instead of dividing everything by 2, is to multiply by the reciprocal. Right? The reciprocal of 2 is going to be 1/2. Now, multiplying by 1/2 might be a little bit easier for some of you than dividing it by 2. All right, so, and if you didn't recognize it, I'll show you the other way that you would have done it, right, which is essentially the same thing. You would see that the 2 and the 2 cancels out, and then you get 1/3 x minus 1/2. And then you see that the number in front of x is 1/3, and then you get m equals 1 over 3. All right, and if you didn't want to do that, if you didn't like multiplying by the reciprocal, you would pretty much solve it the exact same way, just dividing everything by 2. And then you get over here negative 1/2, but then 2/3 x, or 2/3 x divided by 2, you would have to keep change flip, right? So keep the 2/3, change division to multiplication, and then flip the 2, right? It's going to become 1 over 2, and then it's essentially the same thing, right? But maybe it's easier for you to comprehend, right? And then you see that the 2's cancel out, and then you get 1/3 x minus 1/2. Right, the y-intercept here doesn't really matter, right? We don't care about that. We're just being asked for the slope. Okay, good. And then when you look at the next one, this is an equation in standard form. If you remember at the very beginning, I said that there was a formula for finding the slope in standard form. right? And it's going to be, you don't have to remember it. It's going to be negative a over b, right? And if you have ax plus by equals c, then you can see over here that your slope is going to be negative 2 over 3, right? So negative, the number in front of the x, divided by the number in front of the y. So you get m equals 2/3. Now, I told you guys you don't have to remember it, so if you don't remember it, then this is how you would do it, by converting the slope-intercept form, right? Get the y by itself. So subtract 2x from both sides, and then you get 3y equals negative 2x plus 5, and then divide everything by 3. And then you get y equals negative 2/3 x plus 5/3. And then you see that the number in front of x is negative 2/3. All right, good. And then for number 16, it's another equation where they give you 2 points. I mean, not an equation. It's another line where they give you 2 points, or it's not even, it doesn't even have to be a line. It's just 2 points, and you want to find the slope in between them. All right, so we're going to label x1, y1. This is x2 and y2. All right, so our slope is going to be y2 minus y1. So we have 3 minus 3 over x2 minus x1 is going to be 4 minus 5. And then we get 3 minus 3 is 0. 4 minus 5 is negative 1. Now 0 on top, this is okay, right? This is just 0. So we get here m equals 0. All right, what kind of lines have a slope of 0? All right, these are horizontal lines, right? So this is a horizontal line. Right, important to recognize, and you can also recognize the y value does not change. Right, so this is a horizontal line, and it's going through y equals 3, right, and it's going to have a slope of 0. All right, just 4 more on this page. The first one, again, if we're given an equation, always try and convert it to slope-intercept form, right? This is in standard form, though, so there is another way that you could find the slope. But I feel like maybe it's a little bit easier for you guys to learn just one way to do things, right? And just master that. So that's what we're going to do. We're going to try and get the y by itself to convert it into slope-intercept form. So let's subtract 3x on both sides. And then we get 4y equals negative 3x plus 5. And then divide everything by 4. So we get y equals negative 3/4 x plus 5/4, and then we see that the number in front of the x is negative 3/4. Negative 3. Whoa. Why am I having a hard time writing that? Okay. Negative 3 over 4. And then there's your slope. If you remember the other way, right, this is in standard form. Right, so we have AB. So we can just say that m is negative a. Right, so negative 3 over b. Right, and we get the same thing. Right, it's perfectly fine. Okay, next one. We have 2 ordered pairs. Right, when we have 2 ordered pairs, we use the slope formula. Right, so we get x1, y1, x2, y2. All right, so we get y2 is 5 minus y1 is 2. All right, x2 is 4, and x1 is negative 3. All right, don't forget that negative. Don't make a little sign mistake. All right, 4 minus negative 3 becomes 4 plus 3. All right, so we get 4 plus 3 is 7 on the bottom, and then 5 minus 2 is 3 on the top. So we get our slope is 3 over 7. All right, and then the next one, we have 3x minus 1 equals 5. Again, don't try to solve for x. Think about it. What kind of slope does an equation with just x have? Right? What kind of line is that? Right? If we have something that says x equals something, this is going to be a vertical line. Right? A vertical line has what kind of slope? Undefined. So we say m is undefined. All right? I didn't go through the work of solving for x because that wasn't going to help you here, right? If you get x equals, we could have done the same thing as we did in the previous slide with the y, right? 3x equals 6, and then we get x equals 2. right? Some of you this might even confuse some of you even more, because then you have a number and then you say, oh, m is 2. The slope is 2. Right? It's not going to be 2, right? This just means that you have a vertical line crossing the x-axis at 2. Vertical, right? X equals is vertical. All right, and these have undefined slopes. All right, hopefully you're okay with that one. And then the last one on this page. Again, we have 2 points, so we can label x1, y1, x2, y2, and then just find the slope using the formula, right? So -5 minus -2 over -3 minus -1. All right, and then again, don't let the the double negative confuse you, right? That just means you're adding, right? Minus a negative is a big plus, right? So -5 plus 2 is going to be -3. -3 plus 1 is going to be a -2. And then negative divided by negative cancels out. So we get the slope here is 3 over 2. All right. Hopefully this lesson wasn't too bad. All right, this is just the first one of chapter 2.